Welcome back. In this session, we're having the second part of measurement in the physics. So let's begin. I'll be treating basic, particularly measuring instruments. So, what are the objectives of this session? The students must be able to measure some physical quantities with the use of the measuring instrument. They must be able to distinguish among the measuring devices and others. So let's begin with the first physical quantity. Let's begin with length. And as we learned in the last session, we learned that length is one of the fundamental quantities. It is one of the most important basic quantities in physics. So we are going to be learning how the quantity length can be measured and the types of devices we can use to measure length. Okay, so let's begin. Firstly, we have the calipers. We have the calipers. So uh, this caliper is used to take the diameter of a shape. As we learned in the last class, we said the diameter, height, breadth, those quantities are also length. They are also length. When we refer to height, they are also length. So it doesn't mean the word length should be used only. So we learn the calipers is used to measure the diameter of an object, of a cylindrical object. So looking at this diagram here, we have the calipers here, and this is it. This is diagram of the calipers. We have it here, and here is the device. Here is the object, and what we are trying to do is to measure the length of this object, which is the diameter of the object. So how is this done? Having looked at this, we would have understood that this calipers is used along with another device, along with another instrument, which is a meter rule. So let's explain this. So the caliper is taken and used to measure the width of that object, diameter of the object, like this. Since it is used to measure, we cannot determine the length that has been measured unless we place these calipers on a meter rule. And here is it. After the diameter has been measured, when it is placed on it, this can be expanded and this can be compressed. So this is not its fixed size. So after it has been measured, it is placed on a meter rule. After when it's placed on the meter rule, they will be able to determine the length of the diameter. We will determine the length of the diameter. That's very simple. So what is it here? We have 2 centimeters. We have 2 centimeters here. So that's the way we can use the calipers. Say for example, we are asked to calculate the volume of this object. We have to calculate the volume of a cylinder, like the volume of the cylinder is calculated with the formula pi r square h, the pi r square h, or perhaps okay pi r square h. Yes, as we all know, pi is equal to 22/7 or 3.142, the radius and the height. How do we determine the radius now? So we have to calculate the volume of this cylindrical object. So looking at this now, okay, so for instance, if okay, so let's change the color. Here is the object. Let's calculate the volume of this object. And in mass, we know that the calculate the volume, we use the formula pi r square h to get the volume of a cylinder. So we know pi is equal to 22/7. Sorry for this. So okay, we haven't determined the radius yet, and we know the height. How do we determine the height? By getting the length of this, which is very simple. By the use, we can determine it with the use of a meter rule. So we can determine it. So this is should be gotten. So how do we determine the radius? And we know the radius is from here to here. How do we do that? Like we have thought, we know that diameter d is equal to the 2 times radius, which implies that from this portion here to the other side, because it's a three-dimensional shape, it's not a plane shape. So here from that portion to the back side, wait, okay, from this portion to the back side is diameter. It is the diameter. So we can actually determine the diameter with the use of these calipers. So after measuring it, then place it on a meter rule to get its length. So after getting the diameter, say diameter is 4 centimeters, what do we do? How do we now get the radius? We say, based on what have been written here, we have that if diameter is equal to 4, if diameter is equal to 4 centimeters, then the radius is equal to what? Diameter over 2, which is equal to what? 2 centimeters. 2. Then we insert this here, then we get the height and use the value of the pi, then we get the volume of the cylinder. So now let's move to the other one. Okay, we have the statement here. Calipers are used to measure length on solid objects that are in cylindrical form. The jaws of the calipers are adjusted until they touch the object in the correct positions. The length between the jaws is then measured on a graduated scale. The vernier caliper. The instrument has two sets of jaws. Okay, before that, okay, we have, sorry, the instrument. Let's start with this. This can measure length more accurately than the meter would. To measure small length to the nearest 0.1 millimeter. Okay, before I proceed, the vernier calipers is also another instrument that is used to measure length. It is used to measure length. So this can measure length more accurately than the meter rule. To measure small length to the nearest 0.1 millimeter, e.g. the thickness of a meter rule. We can determine the thickness of a meter rule with the use of the vernier calipers. The internal and external diameters of a tube, this is used for the internal diameter, while this is used as part of the caliper is used for the external diameter. Or the diameter of a rod, we use vernier calipers. It stated that the instrument has two sets of jaws and two scales. It has two sets of jaws, and these are the jaws here. The first one and the second one. The first is used to measure the internal diameter of a tube, while the other one is used to measure the external diameter. So, and two scales. It consists of two scales. You get to see it clearly in the next slide. So, where is the first scale? Here is known as the main scale, and this is the vernier scale. This is the main scale and the vernier scale. The vernier scale, which slides on the main scale, as you can see, the vernier scale is sliding, or it slides on the main scale. The vernier scale slides on the main scale is a smaller scale which enables us to measure a fraction of the smallest division of the main scale. The main scale is calculated in centimeters and millimeters. So now, okay, let's sorry. Okay, for any measurement, the reading on both the main and vernier scales are added together. So now, how do we determine the length of an object? The length of an object with the use of the vernier calipers. That's what we are looking at now, which is the reading. So for any measurement, the reading on both the main and vernier scales are added together to obtain the reading of length. So we make use of the reading on the main scale and vernier scale to obtain the reading of the length on the length. So now looking at this, now we have this. Okay, now let's take a look at this. This is an example of, okay, before this would have been obtained, we would have placed our object here. We would have placed our object here before we can obtain the diagram that was shown earlier. We will have placed the object here to determine the diameter or the thickness or whatsoever. So after having done that, then on the male and female scale, on the male, and our readings will be taken from the male scale and the vernal scale. No, we have here, as I stated earlier, the vernal scale lies on the main scale. Therefore, this is the vernal scale while this is the main scale. So the main scale reading here, so I also, the main scale could and the vernal scale could be in millimeters or centimeters. It depends. It depends. It could be in millimeters or centimeters. So now looking at this now, supposing this was, let's take a look at it if it was in centimeters. Let's forsake this here. So how do we measure it? What do we do? We take the main scale reading first, which is 22 millimeters, but we are not using millimeters. So how do we calculate it in centimeters? We have 0, 1, 2, 3, 4. Now please wait. Okay, before we get to that, so now what do we do? Looking at this here, we find out that this vernal scale starts from here and ends here. So when we are taking the main scale reading, which is this one here, we will be taking the reading and stop. We make sure we take the reading and stop at this point. That means line before the point this vernal scale starts. That means here, after this point, that's where the vernal scale starts. So we're taking our reading to that point. We'll be taking our reading to that point. So when we make use of the meter rule or a ruler in our various environments, we can use it. We know that this is 0, here it's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 to 0.9, then 1.0, 1.1, 1.2, so 1.5 here, 1.67, 1.8, 1.9, 2.0, 2.1, 2.2. That is, we have 2.2. So we write that is the main scale day. Here, what do we write? We write, let's erase this. So we have for the main scale reading, let me write that out. For, okay, sorry, let me expand this. For the main scale reading, we have what? Well calculated 2.2 centimeters. So because we are assuming it was in centimeters, which is what, 2.2 centimeters. So let's leave this for now. So for the vernal scale, how do we calculate it? We do what? Now we need to be very careful here. So here this is 5. Normally this will be given to you, this value here, in order to be able to trace it. So we have one for, no, we've calculated the main scale now, the vernal scale reading. We have 1, 2, 3, 4, 5. Okay, that's correct. We have 1, 2, 3, 4, 5. So now we want to determine the reading on the vernal scale. What do we look at? We look at the point of coincidence. What do we mean by that? That is where the main scale coincides with the vernal scale. Looking at this here, where these 2 points meet each other, where 2 points meet each other. Look at this one doesn't meet any points, doesn't meet, but looking at this one here, it meets the points on the vernal scale, on the main scale, they meet each other. So that is known as the points of coincidence, the vernal scale pointer of coincidence. So that's where we'll be reading. That's the points we are going to be reading on our vernal scale. Take note. So how do we do that? If this is 5, then this definitely this is 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4. Then the point of coincidence is 4. But we are not gonna write 4 only into as the vernal scale reading. Vernal scale reading. We are not going to be writing 4 only. What do we do? It was actually listed there, maybe you did not read it, that this can measure, the vernal calipers can measure length more accurately than the meter rule. So to measure small length to the nearest 0.1 millimeters, e.g. okay, so now to measure small length to the nearest 0.1 millimeters. So this statement will be applied now. To measure small length to the nearest 0.1 millimeters, which is the vernal caliper. So looking at this reading here, we have got 4 as the point of coincidence, which is our vernal scale reading. So what do we do? Then we multiply 4 by we multiply 4 years by 0.1. So that means we multiply 4 which is the main scale reading, by what? 0.1 millimeters. Yes, we do that. 0.1 millimeters, which is the value we just saw earlier. Multiply 4 by 0.1, so this is the default value for when you are taking the measurement. Multiply 4 by 0.4 meter to get that. So what do we get? 4 times 0.1 should give us 0.4 millimeters. So we've taken the main scale reading and vernal scale reading, and do not forget we stated that the reading on the vernal scale is the sum of the main scale reading and total and the vernal scale reading. So what do we do? The total reading is definitely going to be what? Total reading will be what? The main scale reading here, which is 2.2, plus 0.4, which is the vernal scale reading. Guess what? Get to 0.6 centimeters. So we've actually gotten this. We've gotten um oh sorry, there's a actually a mistake here. Let's erase this a little bit here. We stated earlier that this here, okay, where is it? This is to measure small letter to nearest 0.1 millimeters. This is in millimeters because we are actually working in centimeters here, but this is a millimeter. So what do? We convert 0.1 millimeters to a value in centimeters, and what do we get? We get 0.01. We get 0.01. So that is it. If 0.1 millimeters here is converted to a value in centimeters, we get 0.01. So this is the default value for when we are working in centimeters. So now what do we get? 4 times 0.01 will give what? 0.04 centimeters. Then the total reading, which is the reading on the main and vernal scales, is going to be 2.2 plus what? 0.04 centimeters. We get what? We get 2.24 centimeters. So that is the total reading. So now what is what we've done here? Okay, and what has been done here? We are definitely going to get the same answer. We have 20.4 here and we have 2.24. So when this is converted to a value in millimeters, we are going to get this. So now let's work with the let's work with millimeters. If the instruments were calculated in millimeters, how do you solve it? How do you work it out? What do we do? So main scale reading here. So how do we determine the main scale reading? They are the same. We carrying out the same steps. So let's look, watch 0, 1, 2, okay, 3, 4. So we are taking our reading at the point immediately preceding the point where the vernal scale starts, which is here. So when we are measuring, when we are reading a scale in millimeters, specifically a meter rule, we don't increase the value by 0.1. What did I mean? We said here 0.1 is 0.2. We are actually increasing the value by 0.1. 0 plus 0.1, we get 0.1, 0, 1, 0.1, 0.1, 0.2. So we are actually increasing these values by 0.1, but we are not doing that here. What do we do? Here we say from here, let's assume we are starting from here. Here 1, we see 1 1. For millimeters now, we say 1 1, 1 2, 1 3, 1 4. Here 1 5, 1 6, 1 7, 1 8, 1 9, 2 0. Yes, 2 1 2 2. That's it. That's why that's how 22 is gotten. 2 1 2 0 2 1 2 2. So that's 22 millimeters. And while the vernal scale reading is equal to, here we have 1 2 3 4. 4 times what? 0.1 millimeters, like we stated earlier. This is a millimeter, so 0.1. Then this is multiplied together, we get 0.4. Then total reading is going to be 22 millimeters plus 0.4, which is 0.4 millimeters. So that is it. So now let's take this exercise together. So the diagram above represents a portion of the vernal caliper. What is it? Excuse me. How do we do that? So let's get the main scale reading first. I think I can erase this. So the main scale reading is how do you do that? So this is the points we are going to be reading because this is where the vena scale starts. Then we have okay, see, is it says, we also need to note um the graduation of the instrument. So it's graduated in centimeters here. So what do we do? We have 6, then we are definitely going to be increasing the value by 0.1. We have 6 here, this is going to be 6.1, 6.2. Therefore the main scale reading is 6.2. Main scale reading is equal to what? 6.2, 6.2 centimeters. So for the vernal scale, how do we do that? We have 0 here, 1, 2, 3, 4, 5, 6, 7, 8. So we are taking a point where the vernal scale coincides with the main scale, and here is it here. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 9. And we don't write 9, we have to multiply 9 by the accuracy of the vernal caliper. So this is vernal scale, which is what got 9 be 9 times 0 point what, guess what, 0.01 centimeters, definitely centimeters. So for vernal calipers, this is its own default one, 0.01 centimeters. Then we get what, 0.09 centimeters. Then the total reading is 6.2 centimeters here. So okay, let me write that down, plus 0.09, which is going to give that's 6.29 centimeters. So that's actually the answer, 6.29. So the answer is E, option E. So that's it, that's how you can determine the reading. So now let's move to another instrument you can use to measure length, which is more accurate than the vernal calipers. Like we said earlier, the vernal calipers is more accurate than the metal, but this here is more accurate than the vernal calipers. It is known as the micrometer scale gauge. Micrometer scale gauge. The micrometer scale gauge. So for accurate measurement of still smaller length, such as the diameter of a wire, the diameter of a small ball, e.g. a pendulum ball, or the thickness of a piece of paper, we use the micrometer scale gauge. It can measure to an accuracy of 0.001 centimeters before any measurement. Okay, yeah. So here now we have it can measure to an accuracy of 0.001 centimeters. For the meter rules, we learned that that can measure to an accuracy of 0.1 millimeters or 0.01 centimeters. But here for micrometer scale gauge, it can measure to an accuracy of 0.001 centimeters or 0.01 millimeters. So before any measurements are made with the scale gauge, its anvil and spindle should be closed to check for zero error. Here is the anvil and spindle should be closed to check for zero error. Like the vernal calipers, the micrometer scale gauge has a main scale and a vernal scale. Here is the main scale, and this is the vernal scale. Okay, so here is main scale, vernal scale. The vernal scale is graduated in millimeters. The main scale here is graduated in millimeters. So that's it. So now let's take a look at the reading. How is it read? So to measure with the instrument, the object is placed. So we have taken the main scale, we extracted the main scale and vernal scale out of the object after the reading has been taken, after it has been after the instrument or the device, the object has, after the length of the object has been taken. So how do we measure this now? That's what we are looking at. To measure with the instrument, the object is placed between the jaws, that is the anvil and the spindle, which are then closed using the ratchets until the object is firmly gripped by the jaws. So like you can see here, the main scale reading is then noted to the nearest graduation. The main scale reading is denoted to the nearest gradation. Okay, we denote. So now the main scale reading here, how do we determine it? We have zero here, which is zero. Okay, we have one, two, three, four, five. So six, seven. You have a little one here, so that's 7.5. Yes, zero, one, two, three, four, five, six, seven, 7.5. So that's the main scale reading. The main scale reading is then noted to the nearest gradation 7.5 millimeters. We then note the reading on the circular vernal scale, which is this. The vernal scale of the micrometer gauge, micrometer scale gauge, the circular one. The readings on the two scales are then added, giving 7.5 plus 0.25. So the readings on the two scales are then added, giving 7.5 plus 0.25. So the vernal scale, the reading on the vernal scale here is the point it coincides, where the main scale coincides with the vernal scale, and which is 25 here. You don't just write 25, you multiply it by the accuracy of the micrometer scale gauge. And we like that it can measure to an accuracy, it can read or measure to an accuracy of 0.01 millimeters or 0.01 centimeters or 0.001 centimeters. Yeah, let me write that down here. It can measure to an accuracy of what? 0.001 centimeters or 0.01 millimeters. So now we dey note the reading on the circular vernal scale. The readings on the two scales are then added, giving 7.5 plus 0. So we have 25 here. So it depends on the gradation of this scale. So if it was in millimeters, then we multiply 25 by what? By this 0.01 millimeters. So we get 0.25. That's how 0.25 is gotten here. So then 0.25 is added, the vernal scale reading is added to the main scale reading to get this. If the or when it's converted to a value centimeters, get this. So if the instrument has any zero error, this is then added or subtracted as the case may be. So if the instrument has any zero error, this is then added or subtracted as the case may be. So that's it. Okay, we have measurements of volume. How do we measure volume? Okay, so rectangle. So now let's take another instrument, another quantity rather, volume. So with measurements of volume, we have the rectangular block. So we can obtain the volume of a rectangular block by measuring its length, breadth and height. So examples of rectangular blocks or regular shapes are cylinder, house, laptops, books, chocolate, bed, etc. So the volume is given by length as breadth and height, which is very simple. So get the length, breadth and height of the object to determine the volume. But what of when we are measuring irregular blocks, those blocks that we cannot actually determine the length, their breadth like that. Example is stone. So how do we do that? So measurement of volume, irregular solids. So the volume of an irregular the volume of an irregular solid, e.g. rock, is obtained by immersing it completely in a measuring cylinder containing a liquid in which the solid is insoluble. The volume of the liquid displaced gives the volume of the solid. So let's give an explanation of that. The volume of an irregular solid, e.g. a rock, so is obtained by immersing it completely. So here is an example of the irregular solid. How do we determine its volume? It is obtained by immersing it completely in a liquid. So here is a container containing a liquid. Here, okay, can we see that here? So when this object here is placed into this water, into this container, it's what? The volume of the liquid will be displaced. That means the volume will increase of liquid. That means the quantity of the liquid will increase. So as it increases, we can actually determine the volume of the object with that. So when that increases, we have to watch very well. We would have noted the reading here. Maybe this, if this was about maybe 10 centimeters. So when the volume increases as this is dropped in the water, maybe it increases to 20 here, which implies that 20 minus 10 will give 10. Then 10 is going to be the volume of the regular solid. So the volume of the solid liquid displaced gives the volume of the solid. So here is the volume of the object as the liquid is displaced after the after immersing that solid in water. So and also you should know the solid must not be solid, it must not be a solid that will dissolve in it, it must be an insoluble solid. So likewise here, this is we can use the Eureka can. This can is known as the Eureka can. So after the liquid is poured here, when the object is placed in the water, it displaces the volume of the object, that the liquid that will be poured out of it will be passed through this funnel, through this passage here. So we can actually get the volume of the water with this cylinder here, get the volume. That is it. So water displaced by stopper, and here is the measuring cylinder. So that is it. Very simple. So mass is defined as the quantity of matter or stuff contained in a body, while weight is the force or pull with which the earth. So mass and weight, sorry, mass only. So mass is defined as the quantity of matter or stuff contained in a body. Mass is defined as the quantity of matter or stuff contained in the body. The mass of the body is measured with a balance of which there are various types. So we measure the mass of the body with a balance. So a beam or chemical balance, a liver balance as shown in figure 1.8. So we have different types of balance. The mass of the body is usually measured by comparing it with standard masses. We explain that soon, very soon. To measure with a beam balance, the object is placed on the left hand scale pan and standard masses are placed on the right hand scale pan. So now let's take a demonstration of it. So here is the a diagram of a chemical balance. It is used to measure the mass of a body. So now the mass of a body is usually measured by comparing it with standard masses. So to measure with a beam balance, the object is placed on the left hand scale pan. So the object is placed at the left hand scale pan here, any of these, and standard masses are placed on the right hand scale pan. That means standard masses, that's a definite mass. So we get one standard. So that means the mass of the object that is going to be measured is placed on one, and while the standard mass is placed on the other one. While the standard mass is placed on the other one, or standard masses are placed on the other one. So when raised for weighing, the beam of the balance should swing freely about the pivot in the center of the beam. Okay, standard masses are added until, okay, we have this here. Oh, this is a chemical balance. Sorry, this is not a beam balance. So here, what is explained here is, maybe let's proceed with it, because we have a beam is also known as sorry. Okay, let's proceed with it. We have this: when raised for weight, the beam of the balance will swing freely about a 5 watts in the center of the beam. Standard masses are added until, so standard masses are added until the pointer swings equal number of divisions on each side of the central mark, or the pointer balances on the central mark of the scale. When this happens, the masses in the two scale pans are equal. What implies that standard masses will be added after the unknown masses added here. Standard masses will be added until what? Until the side of the central mark or the pointer balances on the central mark of the scale. So there's going to be a pointer around this area here. So when this happens, the masses in the two scale pans are equal. So that implies that when standard masses are added continuously until what happens, this happens, the pointer swings equal number of divisions on each side of the central mark, or the pointer balances on the central mark of the scale. It's until the pointer balances on the central mark of the scale, then the masses are equal. Then you can actually determine that, oh, this mass, the mass of the masses of these substances are equal, which is to show that there is going to be an unknown mass here, which is going to be the mass of the body we want to measure, and here is going to be is going to contain the unknown masses. It's going to contain unknown masses. So the the known masses, I'm very sorry, here the unknown mass, here the known mass. So known masses are added until the pointer what balances on the central mark of the scale. So when the pointer balances on the central mark of the scale, it implies that the known masses that are added here is are already equivalent to this here, to the masses. So we can actually determine the mass of the body here. So please we need to understand that. So the mass of the object is then obtained by adding the standard masses on the right scale pan. So the working of the beam balance is based on the principle of moment, and its reading accuracy could be up to 0.001 grams. Okay. Thank you for watching. So you need to solve more questions on your own. You're gonna take your textbooks. So when you find anything difficult to solve, when you get it funny, you are not able to comprehend it, you can contact me at hsunny527 at gmail.com or samuelinity527 at gmail.com. So thank you very much. You are highly welcome to my channel. Thank you.